Hello dear learners, once again you are welcome to JCL Tutorials. This is the platform where we teach you social studies the simple way. You'll be able to answer social studies questions, do well in class, and at the same time go out there and become the responsible citizen. Alright, so last lesson we talked about one of the major movements of the earth, and that was the rotation of the earth. Today we are here with another presentation or discussion where I'll be telling you about or teaching you the revolution of the earth. Okay, so like I did state in the last lesson, I mentioned that the revolution is actually deeper, okay, than that of the rotation, because this one has to take 365 and quarter days to complete one revolution. So we saw rotation where we said the movement of the earth from west to east on its axis causing day and night. This time around we are going to look at the four seasons. The four seasons. Here in Ghana, because of where we are located in the tropics, we experience two major seasons. But that has not changed the four seasons that other countries located on other or different parts of the globe experience. So let's get into that revolution of the earth. Okay, now we have the globe here. Take note that as the earth rotates, okay, from west to east, as the earth rotates from west to east, it revolves around the sun. Why? Because we need the days to come by or to pass by to get the weeks, to get a month, and also get the year. Now we are looking at 1 year. Here on the earth, for a year, we have 365 and quarter days. Okay, so we are going to be demonstrating this using quite a lot of diagrams to show how this happened. Now, on this part of the board, I'll take my time and present the globe physically. I'm going to present 4 different globes representing the beginning or the occurrence of the 4 seasons, where I'll come and present it how you are expected as a student or as a social studies or geography student to present it when you are answering a question, because they don't move in that vertical manner, but rather in that elliptical manner. Okay, so we have that circular thing where it goes around the sun. So what I'm going to draw here will actually explain what will take place on the next diagram. So take note, we are going to follow it step by step, and I'm going to explain to you what actually happened during those seasons. But what then is revolution of the earth? Definitions in social studies are very important, and you have to take note that there are technical words involved, and when you use them, it makes you obtain the perfect score or the full mark. And I always encourage students to go for the full mark. So you take your time and make use of the technical words or the key words. Okay. Now, when we say revolution of the earth, so revolution of the earth is the movement, okay, let's take note of these keywords, the movement of the earth on its orbit. So this time round, it is not its axis. Rotation takes place on the earth's axis, that's the north and south pole. But this time we are looking at the orbit. So the sun in the middle, and then we have the earth, and then it's moving on its orbit. The movement of the earth on its orbit. Anti-clockwise. So you have to indicate that anti-clockwise, causing the 4 seasons. So first phrase, the movement of the earth on its orbit. So let me bring this here anti-clockwise. Causing the 4 seasons, and they are so this is what you have to present. If you're able to present this, you can get a good mark for that. The movement of the Earth on its orbit, not the one with apostrophe S, on its orbit, because we see students making a lot of mistakes. They kind of bring this apostrophe there, which means a different thing. So we are talking about a possessive form. Its orbit, anti-clockwise, okay, that way. Anti-clockwise, this is clockwise. Anti-clockwise, causing the 4 seasons. Summer, winter, spring, and autumn. Okay, so this is the definition. How does this happen? What mechanism or in which manner does it take? Let's go into that. So I will move to this side and then indicate the sun here. So I'm putting the sun on this side where I'm going to show that my sun is reflecting. Sun is reflecting. So the rays of the sun. Okay. Alright. Now I have diagram A. My first globe. Diagram B, the second one. The third diagram, the third globe. And then I have my fourth one. So 1, 2, 3, 4, representing the 4 seasons. Now, during the course of the year, they begin at a point in time when one ends. It takes 2 months passing for another to begin. So we are going to leave that 2 month interval. So here we'll begin with that of the first diagram. So we have March. Now with this March, we'll have, after March we have April, we have May, then June. So here, June. So June, okay. I think I can clean this now. Then we have July, August, then September. From there, we have October, November, then December for the 4th one. Then the year ends. Okay. Now, in which nature does or do all these globes take, or the form they take when these seasons occur? So the seasons are actually categorized into two groups. Technically, we have what we call, so let me use a simple spidergram. So you have the seasons, then I have the first group, we call them equinoxes. Equinoxes. And then we have solstices. Solstices. Equinoxes, solstices. So two of these, or two of the seasons, will fall under the equinoxes, and two of the seasons will fall under the solstices. So take note of that. Two major groups that the seasons are being categorized into, namely equinoxes and solstices. Now, which one are the or fall under the equinoxes and which ones fall under the solstices? Now, this is what it means when we say equinoxes. So equi, the word that comes into mind is equal, and I'm sure that keeps ringing in your mind. Then we have this solstices. It talks about the change in daylight, or hours of daylight, or amount of daylight. This one, there is no change in daylight. Under the equinoxes, the north is actually night. It stands for night. So in Latin, north, equinoxes, equal night. So if there is equal night on the surface of the globe, then there is definitely going to be equal day on the other side. Now, something strange happens during that particular time. So we'll talk about when it happens. Two of the equinoxes occur in a year, and two of the solstices occur in the year. So now, which ones are the equinoxes? We have this, and then we have this. I'll be coming back to put the seasons here. You get them after we have looked at these diagrams. Now, this is what you have to take note of. All has to do with the axis of the earth. The axis of the earth. The axis of the earth. As the earth is revolving or going around the sun, the axis of the earth could get to the position where it remains straight or it tilts. When it is straight, it looks this way. When it tilts, it looks this way, like a diagonal line, or it tilts on the other side. So this will occur in one of the months, okay, or once in a period in a year, and this will also occur at points in the year. Then we'll have this also occurring twice in the year, where the earth axis is very straight and the rays of the sun hit its surface and form an angle of what? 90 degrees. So we know this right angle triangle. Why do we say so? Light travels in a straight line. Light travels in a straight line. So if the rays of the sun are straight and they hit the surface of the earth axis, the north and south pole, that has not tilted, it will form an angle of 90 degrees. Now, let's take note of these technical terms. During that revolution, the sun that is thrown, or the sunlight thrown on the surface of the earth, is referred to as the overhead sun. The overhead sun. That's a reflection upon the surface of the earth. So the overhead sun falls on the equator. You know, the equator is just in the middle, and because it remains at its normal or standard position and the earth axis does not tilt, the angle that will be formed will be 90 degrees because light travels in a straight line. So the straight north-south pole meeting the straight rays of the sun. Okay, so the overhead sun is on top of the equator, and at that point in the year, it forms an angle of 90 degrees. Take note of this for objective questions. Good. So we know what is the overhead sun. Another technical way we should also take note of is the inclination of the earth axis. So this is called tilting. When the axis of the earth turns diagonal, okay, when it turns diagonal, whereby one pole will drop closer to the sun rays or to the sun, we say the earth axis has tilted. The earth axis has tilted, or it has inclined. So just like the idea we have in science, inclined plane. So you see the surface look diagonal. So the tilting of the earth axis is also known as the inclination of the earth axis. Let's take note of that. Tilting of the earth axis is also known as the inclination of the earth axis. So we understand overhead sun because I'm going to be using these words to explain what actually happens during the year, on the period of the year. Tilting of the earth axis is also known as the inclination of the earth axis. Now let's come back. We know the 4 seasons are categorized into 2, equinoxes and solstices. Now, this is what is happening. During equinoxes, the earth axis does not tilt. During the equinoxes, the earth axis does not tilt. So it remains straight in the middle. Now, the first equinox occurs, then first solstice occurs. Then, so we have first equinox, first solstice, second equinox, second solstice. Okay? Or, still the same, you can say that first equinox, first solstice, last equinox, last solstice. Nature is very strange, okay, and wonderful as well. So we see what is happening here. The earth moving in such a way that all these things are happening. So let's look at the first equinox and the shape that it takes. So we now look at March. So beginning from March, we see the earth axis. It does not tilt. So straight north, south, then you have our equator, east, west. No tilting, straight. So when the rays hit the overhead sun, hits the top of what? The equator. If I draw a line here, which is tangent in mathematics, touching that part of the circle, straight vertical with a horizontal line meeting, it will form an angle of 90 degrees. That was what I was trying to demonstrate here. Okay, so this is the first equinox, no tilting of the earth axis. Now let's look at the first solstice. At this normal position, the earth moves and gets to June. Then beginning from June, the earth axis, instead of remaining straight like this, will tilt. So we have, I will use broken lines to indicate the normal position. The normal position, meaning it was like this before it tilted. Now, the first tilting of the Earth axis, the North Pole draws closer to the Sun. So we are going to have this. It will tilt at an angle. So if we take this as the axis of the year, which is straight, then in the course of the year, getting to June, then it will begin to tilt this way and become diagonal. That's the inclination. It will incline. The North Pole will draw closer to the Sun. So it will be receiving, the northern hemisphere will be receiving more of the daylight. More of the daylight. Okay, so this is what we are going to see. Since the Sun, I've drawn my Sun on this part of the board, we'll have this. Okay, north, south. So it has tilted, and it tilts at an angle of 23.5 degrees. So the equator will shift down. Okay, instead of it to be up here straight, that shifted down, making the next latitude on top of it, which is Tropic of Cancer, come into close or fall into the direction of the rays of the Sun. So at that point in this period, the overhead Sun, instead of falling on the equator as we saw in March, it will now fall on the Tropic of Cancer. And the Tropic of Cancer, we know, is 23.5 degrees north. That is why we say the Earth axis tilts at an angle of 23.5 degrees. So take note of that. Take note of that. So we have it this way. So first tilting has occurred. Second, on the third diagram, the second equinox, where it will now get back to its normal position again. No tilting. So we have this. Then we have north, south, the east here and the west here. Okay, north, south, east, and west. No tilting. The same thing we saw here is going to happen here. So now the equator gets back to its normal position. The middle, equal hours of day, equal hours of night, equal hours of day, equal hours of night. That is what we call the equinox. The equinox. Okay. So overhead Sun will still form an angle of 90 degrees when it hits the equator. Okay. Now let's come to the last solstice. The last solstice. Diagram 4 or D. So we have this. What is happening here? It tilts again. Then we have the normal position. But this time around, it will be the opposite of this. The first tilting, the North Pole drew closer to the Sun. So the second tilting, the South Pole will now take its turn by tilting closer to the Sun. So we have this rather coming closer and this moving further away from the Sun. So we have our north and south. Then you can have your equator shifting down a bit. Okay, shifting down a bit. Thereby raising, as it shifts down, it raises the next latitude after the equator, which is known as the Tropic of Capricorn. Okay, falling into the position of the equator, because now the equator on this side has shifted upwards. So Tropic of Capricorn will fall, and the overhead Sun will fall on the Tropic of Capricorn. So in December, that is what happens. Okay, so March will have spring. Spring is an equinox, therefore we can put it here, spring equinox. The direct opposite of spring is autumn. So the two equinoxes are spring equinox, autumn or autumnal equinox. Then the rest will go for the solstices. So we will now have our summer solstice and our winter solstice, our summer solstice and the winter solstice. So we know our equinoxes and we know our solstices. Good. If we have spring, then the first solstice, that is going to be summer. Summer. So June is the beginning of summer. June is the beginning of summer. September, then we have a second equinox. Equal hours of day, equal hours of night. Why? Because the earth axis does not tilt. So this is what we are going to have. Autumn. Then, what else? December, last one, which is the solstice. Last solstice. That's winter solstice. December. So, this is what we are seeing over here. We now know the periods in which the seasons begin or occur or start. So 2 month interval, take note of that, and then also take note of the fact that the first one, no tilting occurs, equal days, equal nights, but the second one, something is going to happen. There will be change or variation in daylight sun. Why? Because the earth axis has what? Tilted. I'll come and talk about this and this because they are unique. With these ones, the A and C, because they are equinoxes, the same thing happens. Equal hours of day, equal hours of night. If we understand this to this point, I think I can take this off. We know the groups of the seasons. Then let's look at what is happening in these seasons. Especially the first solstice and the second solstice. Alright, so let's look at it. Alright, so during summer, that's June, so I'm focusing on the B and the D. Because already with the A and the C, which are the equinoxes, we stated that there are equal hours of day and equal hours of night. That means the amount of sunshine or sunlight or the overhead sun on the surface of the globe is equal, okay? It's equal. So, but here there is a variation, there is a change. So one part will be experiencing more daylight or hours of daylight than the other part. Let's take the first one and see. During this period, from June, July, August, these periods, what is going to happen? As the earth axis tilts, areas, take note, areas in the southern hemisphere, southern hemisphere. This is the southern and this is the northern hemisphere. Let me start with the northern hemisphere. Areas in the northern hemisphere, okay, when we say northern hemisphere, the areas above the equator, and the southern hemisphere are the areas below the equator. So, in the areas of the northern hemisphere, this is what is going to happen. Because the North Pole has tilted closer to the sun, and this area is experiencing or enjoying more of the daylight or sun rays or sunlight, this particular area will experience longer days and shorter nights. So, in the northern hemisphere, there will be what? Longer days, shorter nights. So, my L here, capital L here, represents the longer, and the D, small d, the days. Then the capital S represents the shorter, and the N represents the night. But you have to write them in words when you are describing the whole phenomenon, okay? But with this, I'm just using this to make it simple for you. Okay, so areas in the northern hemisphere, longer days, shorter nights. Then areas in the southern hemisphere, that is below the equator, will experience longer nights, shorter days. Why? Because the South Pole is tilted further away from the sun. And what is happening is that it has or is running short of the amount of sunlight. It's running short of the amount of sunlight being thrown on the surface of the globe. That is what is happening over there. Now, let's get to the extreme north and the extreme south. The extreme north is around the North Pole, and the extreme south is around the South Pole or the polar south. What is going to happen in this area? That on the 21st or 22nd, okay, 21st or 22nd of June, 21st or 22nd of June, what is going to happen is that at the extreme north, there will be complete 24 hours of daylight. Okay, that means night, no darkness over there. Then when you come to the south, which is the opposite, there will be complete hours, 24 hours of what? Night. That is what we will experience on, if it doesn't occur on this day, it will occur on this day. That's why you see the 21st or the 22nd of June. So strange, right? So you take note of this, that northern hemisphere, southern hemisphere. Northern hemisphere, longer day, shorter night. Southern hemisphere, longer night, shorter days. So this is how the whole thing turns. If people are living in the southern hemisphere and they are experiencing summer, those in the northern hemisphere experiencing summer, those in the southern hemisphere will experience the opposite, which is winter. And when we come to this, these people will now be experiencing the other side. So you see how it turns. But we'll come to this very soon. But take note of the variation in the daylight sun or the daylight. Okay, the variation in daylight. Longer day, shorter night, longer night, shorter days. Okay. Now let me come to the second solstice, where the opposite occurs. This time around, South Pole is drawing closer to the sun rays, and North Pole has tilted further away. So, which part is going to receive more sunlight and which part will not? The part that is tilted away, which is the North Pole, will receive less amount of sunlight. Therefore, what is going to happen in the northern hemisphere? There is going to be what? Longer nights, shorter days. While the southern areas in the southern hemisphere, because they've been tilted closer towards the sun, there is going to be what? More sunlight. Therefore, at this point, areas in the southern hemisphere will experience what? Longer days, shorter nights, which is the direct opposite of what we are seeing in June. This is December. So before the year will end, all these things will occur. Now, what happens at the extreme north and the extreme south? This is what is going to happen. Just like we indicated here, 24 hours of daylight because it's tilted closer to the sun, 24 hours of night because it's tilted away or further away from the sun. Here, what is going to happen? North Pole tilted further away from the sun. There's going to be what? 24 hours of night. And here, South Pole tilted closer to the sun. There will be what? 24 hours of daylight. This is what is occurring, and the date for that will be when that will occur. There is the extreme north. I'm talking about the extreme north and the extreme south on the 22nd or 23rd of December. 22nd or 23rd of December. So people are wondering, then what then happens? Are there special dates where something phenomenal will occur during spring or March and then September? Yes. So in that March, on the 21st of that March, what is going to happen is that because the Earth axis does not tilt, there is going to be intense sunlight or heat, okay, on the surface of the globe. That means that areas in the middle here, and we know the tropic zone is in the middle belt of the globe or of the Earth. These areas here will receive intense sunlight and heat. That is going to be what is going to happen on the 21st of March. Then coming to its opposite, direct opposite, which is the second equinox, the autumn. What is going to happen? On the 22nd or 23rd, 22nd or 23rd of September, there is something that is going. So in some books you see 21st September. That means any of those dates we will experience extreme or intense sun heat, because here too tilting does not occur. Tilting does not occur. So if you are presenting this you can do this to explain to someone the vertical way by placing the sun on one side and placing the globe on the other side, and showing how the earth axis will tilt towards the sun, and how the globes or the months or the seasons, what actually is going to happen during those seasons. This is just for explanation's sake. But as a student in the exam hall, if you are presenting it as an answer where you have to explain the phenomenon and also support it with a diagram or illustrate with a diagram, you have to use the one that the earth is actually moving anti-clockwise. That is a diagram that is expected of you. So whatever I've drawn here, I'm now going to put it on that main diagram for you to get the whole picture clearly. So as usual, your sun has to be bigger than the earth. So the sun in the middle, you put the sun in the middle, not on this side, as I use this to describe or explain it. Then you can start from here to avoid trouble. Put one globe here, put the opposite here, put one here, and put another one here to get the 4 globes or the 4 seasons. Okay, so I'm starting with this one, spring equinox. So spring equinox, what happened? No tilting, okay. No tilting, okay. So I have my earth axis straight like this. Then my north and south pole. The 2 important lines must be there. Not the south pole, the east and west. That is the prime meridian and the equator. So you indicate that. Then you can write your March on this side. Then indicate that is the beginning of spring. March 21st. We know what happens, intense sun heat. Then you use an arrow to show that the earth is moving anti-clockwise. If you turn the arrow, you lose mark for the diagram, because you might be creating your own universe where you are saying the earth is revolving in this manner. It is rather in the other way, or this manner. So here, what is going to happen? We have the first one. Then I'm presenting diagram B, which is the first solstice. So that is what? Summer solstice. Summer solstice. What happens? Instead of the x-axis to be straight, it tilts, the North Pole tilts towards the sun. The sun is in the middle now, so you can have it tilting towards the sun or drawing closer at an angle of 23.5 degrees. Okay, so then equator shifts down, then you have this. So this becomes June. Then you can have your 21st. Then you can have your summer for this. Then third diagram C. That's the second or the last equinox. What happens? No tilting as usual. So you have this, you have the equator, you have this east and west. Then what you have, this is September. So September the 21st, 22nd, or 23rd, the intense sun heat on the surface of the earth, equal hours of day, equal hours of night. We know that. So you can write a season that is autumn. Autumn. Then the final one before the year ends That's the last solstice. What happens? The South Pole draws closer to the sun. So instead of having its normal position, non-tilting, this time round is going to tilt. South Pole is here. So you have this. Okay, sorry. Let me do it better. Be better. So you can have a better line. You should be able to sketch this with a free hand. South. Then you can have it this way. East, west. So Tropic of Capricorn, overhead sun will fall on the Tropic of Capricorn. Why? Because the Earth axis has tilted at an angle of 23.5 degrees, where the South Pole has drawn closer to the sun. South Pole has drawn closer to the sun. So I'm sure you might be looking at this, how this is this way, and this has tilted this way. It's because I drew the sun on this side. So you have South Pole drawing closer, North Pole drawing closer. So you have this. But here the sun is in the middle. So I have to show that as the Earth is revolving anti-clockwise, it gets to a period or 2 times in a year that North Pole draws closer to the sun with. I can't turn it this way because the sun is no more here. It's now in the middle. And I can't turn this one too because the sun is in the middle. And the South Pole has to draw closer to the sun. I believe you are getting all these technicalities in the illustration or in the diagram. So if you know this, you use your arrows to indicate that that is how the revolution is taking place. So we can have December here, 23rd. You can make it 22nd or 23rd. Then winter. Have your winter. This is what you are supposed to present in an exam. If they ask you, describe how the 4 seasons occur. Okay, the 4 seasons occur as a result of the revolution of the Earth. The presentation has to be organized, well presented, okay, with the keywords. Then you go ahead. Revolution of the Earth is the movement of the Earth on its orbit anti-clockwise, causing the 4 seasons, namely summer, winter, spring, and autumn. You can put a full stop there. Then you go ahead. The seasons are categorized into 2 major groups. 2 major groups, namely the equinoxes and the solstices. The equinoxes are the autumn and spring, while the solstices are summer and winter. You get it, right? During the equinoxes, the Earth's surface experiences equal hours of day, the equal hours of night. For that matter, the axis of the Earth does not incline. The axis of the Earth does not incline, thereby making the overhead sun fall on the surface of the axis of the Earth, forming an angle of 90 degrees. You get that explanation? Yes. Then you move ahead, you talk about solstice. A solstice is where you are going to now mention all these longer days, shorter nights thing, okay, or theories, okay. So during the solstices, there is a variation or change in the daylight sun on the surface of the Earth. This is because the Earth axis inclines. The inclination of the Earth axis is also known as the tilting of the Earth axis. You get it, right? So then you can move ahead and then talk about what actually happens during summer solstice, where the areas in the northern hemisphere experience longer days and shorter nights, and that of the southern hemisphere experiences longer nights and shorter days. Looking at the extreme north, then on the 21st and 22nd of June, there is 24 hours of day, where 24 hours of night at the South Pole. Then you come to the last one, you explain it, break it down in that manner. Then you put your full stop over there. Then you draw the diagram. You illustrate what you said. The diagram must correspond with the what you have actually drawn or explained. Okay, so at times students try to picture the diagram. They draw first and look at it and present it in words or paint pictures in words. But other students who would like to write them in words and later use the words to present their diagrams. So this is what we call the revolution of the Earth. The revolution of the Earth. So the major effect: 1, causing the 4 seasons; 2, causing variation in the daylight sun; 3, if daylight sun is the light we enjoy on the surface of the Earth, know that the sun is still the body that gives us what? Heat. So if the daylight sun or sunlight changes, then it means that the heat is going to change and it's going to affect our temperature. So the third effect will be what? The variation or change in the temperature on the surface of the Earth, because we know if this North Pole or the part draws closer to the sun, more heat will be experienced here, and this part will become colder compared to this part if the Earth axis tilts. That's what we are talking about, the change in temperature. What else? You can add more and more and more. If there are questions as we get along, put them in the comment box and I will address them. But have a nice description, present them in a way that will be understandable. But don't leave out the technical or the keywords, because they are there to make your presentation very rich. Dear learners, we've come to the end of today's lesson. It's been quite an interesting one, and I hope you keep on sharing this video with other people out there. Let them learn and let them also ask their questions. I'll be coming your way with other or more interesting lessons under the significance of some natural features of the Earth. But for now, see you again and take care out there. Bye.